Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Seth's brother Joel. We're here to hopefully show you how to approach taking SAT math questions and also studying for the Math SAT or studying for the English SAT also. The post-2016 test is more of a test of content, of stuff you learn in school. And the SAT people have partnered with Khan Academy to give you a load of practice questions. They even tell you what's going to be on the test, what topic's going to be on the test. So we're going through, and we are going through these questions. You should sign up to the SAT. You should go to Khan Academy and do all the questions. They give you 20 questions per topic. We are at the upper level because you can see this dial is almost all filled in. We already did one of these in function notation, so we're going to do the second one today. And then we didn't do Throwback Thursday yesterday. We didn't meet Thursday, so we're going to do the Throwback Thursday question today as a special treat, even though today is not Thursday. So here we go. Please try the problem, pause it, come back, and we'll go through it together. Okay, if f of x is 3 up to the x power, and let g of x be x minus 1, which of the following is equivalent to this f of g of x, which is function notation, which tells you that you want to process through the function f of x what g of x is. I always say the best thing to do is stop thinking. You just literally substitute. These x's aren't really x's. These are more placeholders. So just to do it, you want to do f of, and then when you see g of x, you literally put in x minus 1. Because this is the function, is how it's defined today, this g of x for this problem, and then f of x minus 1, you throw the x minus 1, you throw this expression, x minus 1, into this placeholder, so it's 3 up to the x minus 1, right? And then they want you to do some fancy stuff here. 3, yeah. Right, F, exactly. This Seth is using a smiley face as the placeholder. It doesn't matter what you use this as the placeholder. Here, the smiley face is x minus 1. If they wanted to make the problem harder, they would do 3 to the x times 3 to the negative 1, which would be 3x over 3. But they did not do that. Thankfully, this is not a question on exponents, although they could have done that too. So it looks like, this is right, the smiley face is x minus 1. So it's 3 up to the x minus 1 power, which looks like it's D. What do you think, Seth?
Yeah.
Not much here. Not much in this problem. If you're not sure how to do function notation, then go back to Khan Academy and start with question 1. This is the 17th question on function notation. If you're not quite sure what we did, well, you don't really have a choice. You have to start in question 1.
So they talk about
there's really not much to do, right? Right, Seth?
Right.
Just standard function notation, right? Just plugging stuff in and following what you have to understand what this means. So I think we did it, right? There's really not much to do, right? Should we move?
Right, yeah.
Okay. We already did one on function notation, but this is our second question, and we'll do a few more. Sometimes people get confused by this, like, what is this? But just understand these x's are really just placeholders. Everything is a placeholder, and you just substitute everything. It's like you substitute the expressions in for what they tell you the placeholder should be. Okay. So let me clear it. Do people see that the answer could have been 3 to the x over 3. That also could have been an acceptable answer, but they didn't do that. Okay, so let's clear. I guess we'll clear all drawings, and then we will stop this, and we will check it out and see how they did it. Okay. First, let's plug in g of x, right? That's exactly what they do. They wrote it out a little fancier, and then they did, since g of x is that, x minus 1, then you just shove it in and plug it in. Let's see what Seth's writing.
Maybe I could have spinach too. Well,
What is Seth putting
but I
there?
have to cook more spinach.
A smiley face, a
Please.
half smiley face.
I don't think it's really that much.
What would that
I ate
be?
some yesterday.
Oh, plug it in. Right. Seth's plugging it in. Okay, very good. Okay, into the socket. That's right. You just plug it in. Plugging in usually means brainless work, and that's not a bad way to view it. You don't really think too much about it. You literally just plug it in. Okay. Okay, Seth. Let's see. So now what we need to do here is we need to clear all the drawings. We need to do that. And then we need to now, we're going to go to Throwback Thursday. Hopefully this opens up in some, oh wow, here we are. Seth, can you still annotate?
Well, I'll tell you something else. There's a lot of rain that year.
Well, so they switched.
Yeah, it switched. Can you annotate? Can you see the question?
Yeah, I did. Yeah.
Okay, so what is Throwback Thursday? On Throwback Thursday, we go back about 20 years, maybe now 25 years, to SAT questions, where the questions were more like, things you've never seen before, or like more intelligence testing as opposed to things you learned in school. So this question looks a little scary. It's actually not as bad as it looks. That's usually the case with these. You think about it a little bit, and then it becomes easier. Anyway, please pause it, give it a shot, and then come back and we will try it together. Okay, so you have this figure that's obviously a geometry problem with three squares with sides 5, 7, and x. ABC lies on the line. What's the value of x? So, what do you think, Seth? I mean, I cheated. I sort of looked at it already. And
okay. I would follow my nose. The first thing I thought of was that we don't really know x.
Right.
But x is, each of these boxes is a square. So x is the height here.
Right.
And there's still little information about that. However, if I look at this picture, it's the same thing. The height of this square is 7, and the height of this square is 5.
Right.
And so this is 5 from here to here.
Right.
Thanks, honey.
This is 7 from here to here, so this must be 2.
Absolutely.
Okay. So when I went 5 steps up, I went up 2.
Right.
Right? And if I go 7 steps up, I go up in proportion.
Yeah.
So I could figure out how much I'm going up. So let's see. It's I'm going up. Let's call it U. Okay. How much do I go up when going across 7? U over 7. The ratio of the U to the 7 is the same as the 2 to the 5.
Right.
Okay. So I could figure out what U is.
Yep.
U is 7 times 2 divided by 5.
Yep.
Okay.
So it's 14.
7 times 2 divided by 5. But the question is, what's x? Well, they told you. The rest of x is 7.
Yep.
Okay. So the answer is 7 times 2 divided by 5 plus 7.
Right.
And then you figure out the math.
Yeah, so that's 14 over 5 plus 35 over 5 is 49 over 5.
Yeah.
Yep, that's how you would answer it. Right, yeah, that's very good. Seth made a ratio. Yeah, so you're saying 2 is the up, 5 is the over.
Could you open it for a chance?
So x is the up, over 7 is the over.
Because
and then you just
otherwise you have to move things around.
Right.
Right.
Yeah. So that was really good. When I was looking at it, I didn't see it as fast as Seth. I actually looked at it from the point of view, which is really the same, which is sort of an interesting thing about sines and cosines from a trig point of view. I don't know this. I don't know this side, but I know what the tangent of the angle is. These are similar triangles.
Yeah.
So I know that the tangent of that angle is 2 over 5. Right?
Yeah.
But the tangent of this angle is u over 7. And the tangents are the same because the angles are the same. And guess what? You get the same equation Seth gets. So that's another way to view it, right? So you can look at it from the point of view of similar triangles.
So when you come up with the answer, you need to remember, after calculating you need to remember to add 7 to it.
Yeah, I bet a lot of people would forget that. That's something to be very, very careful about. Unfortunately, like on an actual test, like in school, you would get partial credit. In fact, you may get 60, 70% of the question right. Seth, you've graded a lot of tests. Let's say someone just got the U and did it a very clever way and didn't answer the whole question. How much partial credit would you give?
Oh. Well, let me think. The way I would approach this is as follows. I would figure out each of the steps. This is getting the 2 from here is one step.
Right.
Right?
Yep.
Getting the marking off that you're going to that you need to find out what U is would be a second step.
Yep.
The 2 to 5 equals U to 7 would be a third step. Solving for U would be a fourth step. And then adding 7 to it would be a fifth step.
Wow.
So I would, using that strategy, I would give them, 80%.
Yeah, which is very nice.
It's generous, yeah.
Very generous, but on the SAT, guess what? 0. So it's a little crueler than So you got to remember to add the extra. Okay, so we gave.
I figure a problem like this in a class, we would ask the students to show their work.
Right. Right. Okay. Yeah. And you use constant slope. My justification was
slope is tangent.
Right. Yes. Seth's using constant
tangents. Constant, same thing.
Constant tangents. Yes.
Yeah.
Oh, right. Yeah. Look at that. Yeah. Wow. Is that? I guess it's not a coincidence that the word tangent. These things are tangent. Is that?
You wouldn't let me get to that. There is if you draw the unit circle.
Yeah.
And display on the unit circle a central angle.
Yeah.
You could write out. You could identify a line whose length is the tangent of the angle.
What? Okay.
You want to see that?
I guess this may be the time.
Okay.
This
must be the time.
This may be the time. Notice that Seth and I are justifying everything with Seth used constant slope, I use constant angle, similar triangles. This may be the time. Ready, everyone? Where do they get the word tangent, and how does that relate to the unit circle? How does this work?
Okay.
So we're about to see something
I'm going to use fancy.
So can I clear the drawings?
Yes.
No. Let me not clear the drawings. Let me clear
the scribbling.
This stuff, because we want to see this whole thing about how the tangent relates to this problem.
Yeah.
And the unit circle.
Yeah.
So just give me a minute to do some housekeeping. The Zoom thing is frozen. in terms of erasing.
Well,
I
just
know why it's
exercise
erasing. Wait,
patience.
I know why it's erasing, because maybe I may have been in Zypord. I didn't even know where I was. Should I just try clearing the... Maybe I'll just try clearing the whole thing. Let's see. Oh, then I'll tell you what. Exercise patience. Very good idea, Seth. I like that. Unfortunately, everything is frozen. This is bad. Can you draw on this, Seth? Does this give you enough space?
Well, if you could get rid of the stuff at the bottom.
Wait. I know the problem.
What?
There we go. Now we got some serious space.
Okay, here we go. Right. So, I activated drawing a circle. Let's see if it works.
Go ahead.
There is a circle.
Very nice circle.
Right. And now, let's see. We're going to draw some straight lines.
Okay.
The middle of the circle, I mark one radius.
Okay.
Right?
Got it.
And let it be the unit circle. That radius is, therefore, that radius is length 1.
Okay.
Now, I draw another radius. Okay.
Okay.
And that radius marks out the angle theta.
Yep.
Right?
Yep.
So where's the tangent?
Well, the tangent, if you drew a right triangle, which I'm not going to do, I don't want to muck up Seth's beautiful drawing. If you dropped, well, I'll do it, then I'll come back to it. If you go like this, make a right triangle.
No. No.
Okay. Oh, but
that is a guess.
Circle. Oh, the tangent to the circle is here.
Here is another right triangle.
Right. There's a tangent to the circle. Right.
And what we have is that the length of this segment,
right,
is
right. Yeah, it's because
the tangent of the angle.
Right, because the
and this, so the segment that has the tangent marked off on it is a segment of the line, a line that's called a tangent.
Wow, look at that. Yeah. So the tangent is actually the length of a line in the unit circle.
It's not in the unit circle.
No.
It's out. It is the length of a segment of a tangent to the unit circle.
Right. That's very cool.
Now let's do non-tangent.
Okay.
Let's use green. Let's use green for a non-tangent, and do what Joel did. You see where the second radius meets a circle and drop a perpendicular.
Okay.
This is what Joel did.
Right.
Okay, that is a right. We have a right triangle.
Yep.
But it's the green line is not a tangent.
No, it's not.
Well, the length of that green line is the sine of the angle.
Right. Yep.
Okay?
Got it.
What we had spoken about before is that in the old days they imagined they imagined, let's see, they imagined
a bow and arrow.
a bow, right? Here's our bow. Here's our bowstring.
Yep.
And our bowstring is a string, also known as a sinew. How do you spell sinew?
EW, I think.
EW. A sinew, or a tendon.
Yep.
That the people who would, before they made bowstrings out of nylon, they got from some poor animal. They slaughtered the animal and took out the animal's tendons.
Yep.
And the sine of the angle is half of the length of this string or sinew of the bow.
Right.
Yeah.
Yep. Yep.
Yeah.
Wow, that's very cool. And then you can see the tangent's always a little bit bigger than the sine. Tangent is bigger than the sine because you're dividing the sine by a cosine, and cosine is always less than 1. So you can see visually that plus it makes sense that the tangent's bigger than the sine because the tangent's on the outside of the circle. The length of the tangent's on the outside. So that's very cool that the tangent actually has a distance related to it that is actually literally a tangent to the circle. That's very cool. Wow. Okay, everyone. So I think this closes up our Friday, but also Throwback Thursday with a question that looked a little challenging, but when you sort of analyze it, it's not that bad. That's the way most SAT questions are. Very conceptual. Okay, everyone. Have a great weekend, and we hope to see you next week. Please like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestionoftheday@gmail.com. Okay, everyone. Have a great day.